Welcome to Study Loop.
Alrighty, we've got firemen and a high pressure hose to shoot water at a building. So we know that the speed of the water is 25 meters per second. Whoops, three significant digits. The angle of elevation until it takes 20 seconds to reach the building. Okay, so here we got a building, got the hose down here. We've got an angle of elevation alpha, and it's good. Oh, not 30 seconds. Yeah, that would be it'd be crazy. It's 3 seconds. Um, and the building is 45 meters away. So the distance to the building, which I'm just going to write as x. You know what? I'm not going to write it as x. I'm going to write it as d. D is 45 meters away. What's alpha? Well, how far up the building is it hitting? All right, I guess we're going to have to assume it's hitting the bottom of the building, which I don't think is going to do much good at putting the fire out, but I think that's what it's trying to tell us. So what's A? Well, I know that at the peak it's going to be halfway there. And the velocity in the y direction at the peak is going to be 0. So Vy peak is Vy initial minus Gt. This is 0, so 0 equals 25. Whoops, I'm just going to write V for that. And then in the y direction would be the sine of alpha minus gt. So t is going to be v sine alpha over g, just rearranging and solving that. Okay, now that's going to be half the t to get halfway. But I want t to get the whole way over. So I'm going to write t half here, and t to get the whole way. So I'm going to write half. I'm going to write half. But wait a minute. We already know t is 3. So t half is going to be 1.5. So I think we can solve this. Alpha is going to be the inverse sine, just rearranging this, of gt half over v. So putting that in a calculator, and I need to set my calculator to degrees. Let's get that first. Got it. I also like to declare my variables. V is 25. T, I'm just going to make t half is 1.5. Okay, so now alpha equals inverse sine of g, which is 9.81. Sometimes I like to declare g. times T over V. So that's going to be 36.1 degrees. Okay, B. Where are we with B here? What's the speed and acceleration at the highest point? Well, I already used that. Oh wait, what's the speed and acceleration of the water at the highest point? Didn't quite answer that. B, but I kind of needed to know that. The speed in the vertical direction is 0. The acceleration is going to be negative 9.81 meters per second squared downward, because there's no acceleration in the x direction. And velocity in the x direction at the peak is going to be the velocity in the x direction all the time, because there's no acceleration, which is going to be v cosine alpha. So let's get that. Where are we here? V cosine. Get my fingers in the right place. 20.2 meters per second. That's an answer, and that's an answer. Okay, C. How high above the ground does the water strike the building? Uh, uh, it doesn't. It strikes on the ground. How high above the ground does the water strike the building? It strikes on the ground. Okay, what have I missed here? Because I created it so it would strike on the ground. They're shooting a stream of water at a building. Cool. The water has a speed of 25 as it leaves the end of the hose. It exhibits projectile motion, which I've shown here. They adjust it until it takes 3 seconds to reach a building that's 45 meters away. I didn't really use D is 45. Did not use that. Okay, so clearly I've made a mistake here. So let's get rid of that, and let's get rid of that. We're not striking the building on the ground because we're given this. So let's try this again. If at first you don't succeed, try again. A, we're given the horizontal velocity. V, in the x direction is going to be the 45 meters, which is D, over the time, which is time total. So you know what I'm going to do? I'm going to call this T sub 1. You know what? No. I'm just going to call it T. So let's go back to the calculator. I'm going to undo everything that I've already done, except I probably could have left V there. Let's move up. Okay, I definitely could have left V. And I could have left, no, I need to make T3. Okay, so now V Whoopsies. Let's move down here. Okay, let's keep going here. V sub x is d over t. Did I declare d? I did not declare d. D is 45. Okay, v sub x is d over t. Well, just to check what it is, it's 15. V sub x is d over t, which is 15 meters per second. Okay, now, what am I trying to figure out? Alpha. Okay, so let's draw this again. It's definitely more complicated now that it's not going to hit the bottom. It's going to hit somewhere up here. And I suspect it's going to be hitting on the way down. We know D here. Okay. So, we're still trying to figure out alpha. Um, 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 um. Okay, so I know V sub x. That's cool. I don't think I want to care about that right here. Draw. I don't think that really applies. This drawing really doesn't even apply anymore. So all I really know is V and T. Okay. So let's keep going. I know V, and I know T. Well, wait a minute. If I know V and I know Vx, then Vy is going to be the square root of V squared minus Vx squared. Okay, let's do that. Calculator. So, I know V is 15. Wait, I know Vx is 15. V, and then I'm going to put a subscript in here. Subscript x. I know Vx is 15. So now V subscript y is going to be the square root of V squared minus Vx. V subscript x. Whoops. Squared. Okay, so Vy is 20. Okay, so now alpha is going to be the inverse tangent of V sub y over V sub x. So let's get that. Equals inverse tangent, whoops, of V sub y, V sub y over V sub x. Okay, so that's going to be 53.1 degrees. And that is the answer recorded by Numerate. So now I'm on the right track. So my problem was I was ignoring the fact that we were given the distance here. If we're given the distance and the time, then we can figure out the velocity. Okay, moving on to B. What's the speed and acceleration at the highest point? Well, Vy at the highest point, again, is 0. So it's just going to be Vy in the x direction, which means it's going to be V at the peak is going to be 15 meters per second in the horizontal direction. Okay. What's the acceleration? Well, the acceleration is just going to be g, which is negative 9.81 meters per second squared downward. Okay, C. How high does it strike on the building? So I'm going to call that y, and y equals y initial, which is 0, plus vy initial, which is just vy t minus 1/2 g t squared. Okay, I think we know all of that information. Do we know t? Yeah, t is 3. Okay, so v sub y times t minus 1/2 times g. I wish I would have declared g times t squared. Okay, 15.9 meters. Checking the answer. Oh my goodness. Oh wait, the answer's not in there. So this is probably right. I mean, I don't know how it couldn't be right because it's one simple equation. Okay, and C. How fast is it moving before it hits the building? Okay, well, we know Vx is always the same. So, V, drawing it, or V sub y equals, V sub y at the end, Vye, is going to be V sub y minus gt. So, let's do that. V sub ye. See if it accepts that. Yep. Equals V sub y minus gt. Oh, but g is 9.81. Cool. Okay. How fast is it moving? So now I just have to do the square root of v sub ye. Okay, squared plus v sub x squared. 17.7 meters per second. So the velocity at the end is 17.7 meters per second. Okay, that was an interesting problem, and it required some extra thought because the distance was given. All right, thank you for watching.